Okay, so first of all, which of these is going to be the central atom? So one thing that's going to be a good strategy is to say things that have the most sticky sides tend to be central atoms. All right, and again, this is consistent with the fact that they said that a lot of times carbon is in the middle. Okay, so we're going to choose carbon to be the central atom. So we'll bring him onto the field. All right, so remember he's no longer on the sidelines if he's on the field. And what we're going to do is we're going to put each oxygen on one side of this. All right, those two guys would make a bond. So when you draw it, remember we made a bond with this sticky side so that that sticky side is still present in the molecule. All right, so we're going to do the same thing with this guy right here, and I'm going to assume that you can kind of turn these dots around in your head. Okay, so what you would initially have is something like this. Okay, so what we're going to do here is we're going to use a strategy where we're going to say that things are going to make multiple bonds so as to get rid of the sticky sides. Okay, so when you take a look at this, how many sticky sides do we have? We have one here, one here, one here, and one here. Okay, so sometimes you're going to have to do this little trick where you realize that even though I've got sticky side, pair, pair, as long as you've got two sticky sides and one pair, you can put those on any of those three sides that you wanted to. All right? So the first thing that I'm going to do is say, okay, these two sticky sides, which are in neighboring atoms, are going to come together to make a bond. Okay? So if they come together to make a bond there, what we're going to have is we're now going to have two pairs of electrons being shared between that carbon and that oxygen. Okay, let's just redraw what we still have. Okay, we still have that sticky side there. We still have this. All right, and so what I'm going to do here is I'm going to just have this sticky side and that pair switch sides. All right, and the reason for that is it's now easy to see, okay, I've got two electrons on neighboring atoms that can come together to make another bond. Come in there to make another bond. They're no longer going to be sticky sides. They're going to be another shared pair. Okay? And the way that you can represent this molecule is to draw it like this. And again, let's take a look at our pieces again. Make sure that we haven't forgotten any electrons. That's 4 plus 6 plus 6. That's a total of 16 electrons. Okay, so 2, 4, 6, 8, 10, 12, 14, 16 electrons. And let's take a look at each atom. Oxygen has 2, 4, 6, 8. Carbon has 2, 4, 6, 8. And that oxygen right there has 2, 4, 6, 8. Okay, so that's another way that you can think about drawing the molecules. Okay, so again, you've got to decide which of the atoms are going to be central atoms and which atoms are going to be on the outside. Carbons are quite often in the middle. Hydrogens are never in the middle. Right? Remember, hydrogen only has one sticky side, so it can never be a central atom. Okay, so let's first just join our carbons. Okay, if you join these guys, you've got to count. Okay, well, after that, how many sticky sides are left? Well, for this one, I would have 1, 2, 3 sticky sides. Same thing on this one there. All right. So again, using the sideline analogy, if once they're bonded there, let's take them off. All right. So what do we have left? We've got two hydrogens. Okay. One strategy is to keep things as symmetrical as possible. So what I'm going to do is I'm going to attach one hydrogen to one of the carbons, all right, and then I'm going to attach the other one over here. Okay, so they're now being used. All right, so let's look at what we have left. We still have 1, 2, 3, 4 sticky sides. All right, but the nice thing is we can show these guys coming in to make another bond. That would make that bond, and then these guys can come in. Okay, so you'd end up with this molecule right here. and that shows a triple bond between the carbons. So just to check our work, let's go back to our original fragments. Okay, you should have 4 plus 4 plus 2, that's a total of 10 electrons. Let's take a look here. 2, 4, 6, 8, 10 electrons total in the molecule. Let's take a look at the carbon, or sorry, at the hydrogen. That's got 2 electrons. This carbon would have 2, 4, 6, 8. This carbon would have 2, 4, 6, 8. And that hydrogen would have 2. So everything's happy. So final answer, this right here. And notice that on this particular example there would be no unshared pairs.